Here's our question. Okay. So they're giving me this big chart, all this money. I encourage you to write that down, or you can reference it on number 3. Probably a little different numbers for you. So we're basically supposed to go through this deal and find out which of those are fair. Remember the whole fair thing, right? Equal in their eyes according to their value system. So it says, which of the 4 slices are fair to Abe? So to Abe. When Abe looks up at those slices, what is it? Some kind of big cake or pie? Yeah, cake thing. Right, we got these slice X. So Abe thinks slice X is worth $2.31. Abe thinks slice Y is $7.11, $3.76, $1.82. That's what Abe thinks the different slices are worth. Well, how do you know which of those is fair to Abe? How are we going to do that? How much money is fair?
Yeah, add them all up.
Yeah, you should add them all up. How do you find? Because fair means equal, right? Equal share, you know. So, what we can do, yeah, you guys are exactly right. Take the Abe numbers and just use calculator. 2.31. You guys brought a calculator today, I hope. You can use that. 3.76, 1.82, 8 and 10. I'm gonna do it by hand, but you guys can do calculator. 10, 20, 11, 12. Is it $15? I got $15 even. So when I added those up, $15 even. Right, so Abe thinks, adding up the whole cake thing, Abe thinks the whole cake is worth $15. That's how Abe feels. That's how much he values it. Okay, so what does that mean each of those pieces is worth to Abe? 4 pieces, just divided by 4, right? What is that? Yeah, thank you. 3.75 is fair to Abe. So you see what I just did? I just added up, got Abe's total, and divided by 4, because there's 4 slices, right? So Abe thinks any piece that's $3.75 or more, to him, is a fair share. That's what it means to be fair, right? Equal value, 1/4 of the value. So you always divide by how many pieces, or how many players in the game, right? All right, so with that in mind then, looking back up at Abe's pieces, which ones are $3.75 or more? Looks like Y, Z, barely. Just Y and Z, huh? He loves Y. For whatever reason, that's his favorite flavor or whatever. Anyway, so does that make sense? Y and Z, and that's why the answer to which ones are fair for Abe is Y and Z. The other two, X and W, Abe doesn't think are fair slices. If he was given those, he wouldn't be happy. He would not think he got 1/4 of the value. He would not think he got a fair share. Is that making sense? Want to try the next person? Who's the next person? Betty. Look at Betty. Betty's got something different going on. What's going on with Betty?
It's already all divided equally.
Yeah, Betty, it's already divided equally. Now, what does that mean? What's up with Betty? Why's Betty got that weird thing going on?
She sees all the slices as the same, I guess?
Right, she sees them all the same. What does that mean?
So, no need to do the math on it, then, right?
Yeah, no need to do the math. Fair share is 4, totally. And what does that mean about Betty?
She doesn't care what piece she is.
She what?
She could get all the pieces.
She could get all the pieces, and she did the cutting. Remember? It's the cutter that cuts them all fair in their eyes because the other people pick. Betty must have cut this cake. And all the rest of the people decided what they thought the 4 pieces Betty cut it into are worth. Betty thinks they're all fair. Remember my whole story about the kids cutting the cookie, right? That's the same thing. The cutter will cut them fair in their eyes. So whenever you see a person where all the numbers are the same, that means Betty is what we call the divider. In the divider-chooser method, she's the cutter. She's the divider. She's the one that cut the cake up, and which means she gets last pick. The one who does the cutting of the cake or the cookie or whatever, or the land, gets last pick. Last pick. So that's Betty. Betty gets last pick. How do we know all that? Because she's the only one with even numbers across. She must have done the cutting. That's what the cutter always does, is makes them even because they know they get the last choice. They don't want to make one better than the other. They might get a bad deal. They know their last choice. All right, so let's go on. So yeah, we don't need to do the math. Betty, that's $4 is fair in her eyes. Let's go to Corey. Can you do Corey? So Corey, you got to do the same thing, right? You got to add up for Corey all the Corey numbers. So Corey, 278, 437, 111. So add them all up and divide by 4. Do that. Good. What's the total? You guys got that for me?
11.
What is it?
11.
Oh, 11? Thank you. 11. And then divide that by 4, 552, 225? 275? 275. 275? Thank you. 275? So that's fair to Corey. Corey doesn't think the cake's worth as much as some of the other people do. But that's a fair share to her. See how we get fair, right? Add them all up, divide by. That's equal, right? No, she thinks the whole thing is worth, she or he thinks the whole thing is worth $11, and 1/4 of 11 is 275. So 275 or more is a fair share to Corey. So which ones are 275 or more? That one, that's it, those two. Corey thinks X and Y are fair. That's why the answer for Corey is X and Y. Oh, by the way, the answer for Betty was all 4 of them, huh? Because Betty's the cutter. She makes them that way. Corey's X and Y. We good? And then it's the same thing for Dana. Got to do one more. Dana, add them all up. Divide by 4. 397. 164. 175. 164. Add them all up. So we get that 11, 20, 11, 17, 330, I think. 6 and 9. Is it $9? Is that right? Okay. 9 divided by 4. Is that 225? I think. Is my math right? Use calculator for all this stuff. So 225. So Dana thinks the whole cake is worth $9. Divided by 4. 225 per piece. 225 is fair according to Dana, because that would be 1/4 of the whole value of the cake according to Dana. Is that making sense what I'm doing, guys and gals? Just add them up, divide by 4. So which one's for 225 or more for Dana? This one, that's the only one, A, or X. So that's why X is the only one that's fair over here to Dana. Dana thinks only X is a fair share. I only like piece X. The rest are not fair. That's how Dana thinks. So we're trying to devise a way to make everybody get a fair share. Fair in their eyes. See how everybody has different opinions? Right? Betty thinks they're all fair. She did the cutting. Whatever the flavors and the whatever, the pudding and the frosting and whatever. Betty cut it in a way that she thinks they're all fair. She knows she gets last pick. The cutter gets last pick. The divider. The rest have different value systems. So they think different thoughts. Okay. So then, let me ask you this. Looking at these, their opinions, everybody's opinions on which ones they think are fair. Is there a way to give them all a fair share?
Yes.
Is there a way to do it? Yeah, you're right. Let me go to the, everybody got that copy down? I'm going to go to the next screen. And I'll just, whoops, that's not what I want to do. Okay, so yeah, there's the answer. How would you do that all fair? Oh, one of them's off the screen. What was Abe? What did Abe like?
Y and Z.
Thank you. Abe liked Y and Z, and Betty likes, and this one's Betty. Betty likes them all, right here. And this is person C. This is person D. That's what they like. Okay. So with that in mind, how would you do it fair? Well, basically, if person D only likes X, and you want everybody to come away feeling fairly treated, that's what this method's supposed to do. You're going to have to give D slice X, person D, Dana. You're going to have to give Dana slice X, because that's the only one Dana thinks is fair. You give Dana any of the other pieces, he or she's not going to feel that they got a fair amount. Make sense? So Dana gets X, that's what this is saying down here. You got to give slice X to Dana. And after you do, now slice X is gone. So what are you going to do for Corey? Corey only liked X and Y. You've already given away X. So you got to give Corey Y, right? You got to give Corey Y. That's what we're saying right here. You got to give Corey Y. Now you've given away X and Y. You come up to Abe. Abe only thinks Y and Z are fair. You've already given away X and Y, so you give Abe Z, right? You give Abe Z, right? Abe gets Z, and now last comes Betty. Remember, the cutter is last. The divider is last. Betty is last, but she doesn't care. She thinks they're all equal. She cut it that way. She knew she'd be last. So what's left over? W. Give her W. She thinks that's a fair share. Nobody else does, but she does. Everybody comes away thinking they got a fair shake, right? In their value system with multiple different values. Everybody comes away thinking they got a fair deal. That's what we're supposed to do. That's the whole purpose of the math. It's a fair share. All right, is that good? We better get to practice now. Be better use of our time. So I'm going to stop there.